in the previous video we learned about how to build an FSM to detect the sequence 10110 in a Mealy fashion. Now here we will see how to implement the same functionality using a Moore machine. Okay, so the basic let's start by elaborating more on what Mealy and Moore means. Okay, Mealy machine, like, simply like, if you want to understand simply, only think about in the terms of output equation. So the output equation which we got for this Mealy implementation was S4 if we are in the state S4, and if we get input 0 D in bar, then only output should be triggered high. Okay, so output equation was involving D in, and D in is seen as an external input for this FSM. Okay, so why you might think why input is being considered as an external input. So if you see a counter, okay, if you see a counter, if you just give an input signal, if you could just give a start signal, it will automatically count and count and count and count till you give the stop signal, or you give a reset signal or something. So these reset and start signals are what are external stimulating inputs. Okay, so this D in is also an external stimulating input. So once you give the start input, it will not require any other other inputs to continue going to the next states. Once you give the start state, it will go from 0 to 1 to then 2, then 3, then 4, then come back to 0 1 if it is a mod 5 counter. Okay, so transitioning from 1 to 2 doesn't require any triggering. It is being done automatically. But here transitioning from state 1 to state 2 requires an input. As long as you don't give an input, it will stay there. Okay, so it is not like if you okay, so that is why D in is being considered as a output, external input. Okay, so Mealy machines, what Mealy machine is, okay, so if the output equation contains external inputs, okay, I'll write like this. Okay, if the Mealy machine contains external inputs, then it is a Mealy machine. Okay, if it doesn't contain any external inputs, if not then it's a Moore machine. Okay, then it's a Moore machine. Now you will understand it a bit better when you actually see the diagram for the Moore machine. Let me just copy this circuit, then we'll go about developing the Moore machine for this. Okay, yeah, so okay, so we were what the state S4 signified, 10110, we have detected till this S4 signifies that we have matched the pattern 1011. The only this 0 is to be detected. If we get a 0, what we previously did was overlapping sequence itself. Okay, so for now we are just talking about overlapping sequences. Okay, if we get a 0 while at state S4, while in the state S4, we will return to state S2. Okay, to detect the upcoming sequences. Okay, upcoming overlapping sequences. If we get a 1, then move to S0. So we would now assign, because for a Moore implementation the output equation should not contain any external inputs, so we are assigning an extra state if we get a 0. So if we get a 0, then only output should be triggered high. But in this case, the state S5 itself is triggering the output. If the FSM reaches the state S5, then the output should be triggered high. In this way we are ensuring that the output equation doesn't contain any external inputs like dn, in this case dn. So output equation, output would simply be S5. Whenever the FSM reaches the state S5, trigger the output. If not, then to continue doing the same thing which we're doing previously. Now if you get a 0, then go to S5. If you get a 1, then move back to S0 pre, okay, to detect the other sequences. Okay, now once we get in state S5, what would we do next? Okay, so if we get 1 from here, okay, so 1 0, the state S5 is representing the output. 1 0, if we get a 1, then it should come here, because the state S3 signifies the matched pattern 1 0 1. Okay, if you get a 1, then move to S3. If you get a 1, if you get a 0, that is 1 0 1 1 0 0, then what is it? Move back to S0. Okay, because it is ruining the pattern. It is not whatever incoming bits is a fresh input rather than a overlapping sequence. So if you get a 0, the sequence is ruined, and then you move back to S0. Okay, if you get a 0, okay, if you get a 0, then move back to S0. If you get a 1, then move to this 101 state, that is S3. Now you can see that this output, this state S5 is a clone of the state S2, because it is doing the same functionality. If S5 and S2 were overlapped, then if we get a 1, then we were moving to S3. Same here, S2, if you get a 1, move to S3. If you get a 0, go back to S0. Same here, if you get a 1, move to S3. If you get a 0, go back to S0. Okay, it is same. Okay, so in some sense we have just replaced or cloned the state S2 and S5. So S5 clone, okay, S5 is a clone of S2. Okay, so now in order to understand what the statement means, the output will be triggered as soon as the state S5 is reached. Okay, we will get into practicality of implementing FSMs. Okay, we have how many states? 1 2 3 4 6 states. We have 6 states. To implement 6 states, you need at least 3 flip-flops. Okay, 3 flip-flops, because 2 flip-flops will only give us 4 patterns. Okay, 4 different patterns. To get 6 different patterns, you will need at least 3 flip-flops. Okay, so these 3 flip-flops, we would assign these numbers. Okay, now we can assign numbers. This state is 0 0 0. This state is 0 0 1. This state is 0 1 0. This state is 0 1 1. This state is 1 0 0. This state is 1 0 1. Okay, this state is 1 0 1. So triggering the output as soon as S5 is reached will mean that we are taking 3. Okay, so we have 3 flip-flops like this. Okay, this is Q0, this is Q1, this is Q2. So we are actually taking, okay, we have to detect 101. Okay, 101 is the thing when we trigger the output. So we take 1 the 0 1. Okay, we actually hard code the output to 1 whenever the output is 101 from these FSMs. So these are flip-flops, D flip-flops. Okay, D0, D1 and D2. Some other combinational logic would be present between these two in order to implement the next state logic. We would not go into that. If possible, I'll cover it in some other video, but remember that the what we need to focus is the output is being hard coded whenever 101 is reached. Okay, you can 101, or it is like 101 here from right to left or left to right is same, so we don't need to think much. Otherwise it would be important if it 101 is MSB this side or MSB this side. Okay. Okay. uh, I think you got a good idea of how we are implementing, what Moore implementation actually means in practicality. So you can see the differences, that the output equation is now only depending on the state 5 S5, where previously in the Mealy machine it was depending both on the state and the forthcoming input, that is D in. Okay, if it was only 0, then only it would trigger the output, otherwise it would not trigger the output. Here, if it reaches the state S5, the AND gate would automatically detect the sequence 101. Okay, and then give the output to be 1. Only for 101 only the output would be 1. Okay, I hope you got a good insight of how what is the difference between Mealy and Moore, and also we have a good understanding of how to go about starting or building FSMs, all that. Okay, thank you.